Thursday agenda 3-4. No, thanks. I'm good. You enjoy it. Well, look who's here, Preston. How you doing? Look at that. You're inside a house.
I know, right?
This is a nice change.
How's your morning going?
How's my morning going?
Yeah, how's your morning
Oh,
going?
you know what? It's going great. I appreciate you asking me because, most people, very few people ask me how I'm doing. And I always ask you guys how you're doing. So I appreciate that. It's going pretty well. I got up pretty early today. My donkey woke me up at 5 a.m.
You have a donkey?
Oh, yeah, I have a mini donkey. His name is
Oh,
Honky Tonk.
Donkey Tonk?
Well, I call him Donkey Donk, but his name is Honky Tonk.
Oh, that's so cute.
Yeah, I'll have to, maybe I can get some pictures together, do a little slideshow of all the crazy animals we have on our farm.
You should show him.
What's that?
You need to show him.
Okay. I'll work on that. Maybe I can put a little collection together this weekend, and I can show you that next week when I see you guys. And we'll go for it. That would be fun. Maybe we should all do that. Like have everybody do a slideshow of their animals, because I have a lot of students that have all kinds of animals, whether they're dogs, cats. We even have a chinchilla. You know what that is?
Yeah, oh.
Yeah. So he's a fuzzy little guy. He's a lot of fun. Really friendly. Chinchillas, I didn't realize how friendly they are. Much more so than, let's say, hamsters. Hamsters aren't that friendly. I mean, I used to have a hamster when I was a little kid, and he bit me all the time. So not too much of a fan of a hamster, but chinchillas are cool. So good morning, guys. Good to see everybody here. So, Natalie, did you bring your cats to join our lesson here?
No, we have some person painting our ceilings right now. So they're upstairs locked away in a room so they don't go crazy.
Yeah, that's keep them safe, right? Keep them safe for sure. Yeah. And so, Logan, tell me about your hamster.
My hamster is literally so mean. He bites me every second he gets.
What's his name? Little Devil or what?
His name is Quibbles.
Well, you'll have to show me your hamster one of these days. You have to bring him on the screen. I'll show you.
I got him right now.
Oh, okay. You mean he's on your desk?
No, he's next to me. He's in a bin in my room.
Okay, that's cool. Well, I tell you, I have my little chinchilla. He's over there. His name is Chili Willy, and he's super friendly. He's got super long whiskers, super furry, crazy little guy.
Yeah.
All right. Well, it's good to see you guys. Turn your cameras on, please. Let's get ready to rock and roll here. We're going to be jumping into chapter 5, as you guys know. And I would highly suggest you get a piece of paper out off to the side, because we're going to do a little work on some of these, because at least I didn't have enough room to do it all on this in your workbook. You know, I work through all the problems, just so you guys know, and sometimes there's room and sometimes there's not, and there's definitely not here. So get a piece of graph paper or just, you know, a piece of side paper here, do a little side work. You know, as you guys know, with me, we show all setup, we show everything in order to get full credit on your assignment. You got to show the setup and process. So let me state that at the very top. That's kind of like standards, setup, and process. And what I want to do, guys, is launch chapter 5 with you guys. Section 1 is on looking for employment. And what I like about this class a lot is that it always talks about real life stuff. So we're going to be dealing with some problems here that is real life. You know, I mean, everything that you're going to see in these problems here, I've done before in the past. There's not one thing that is just made up and not applicable to real life. So get set up and ready to go. You're going to need a calculator, obviously. This is not heavy intensive calculator work. It's just mostly conceptual. And but we are going to do some basic calculator work. So you're going to need something to participate. And again, let's see, Valentina and Chris and Audrey and Cameron and Tristan. I can't see you guys. I like to see you guys so I can get to know you as people. And by the way, just so you guys know, I've talked to you guys last week a little bit about going back. But the decision has been made. We are scheduled to go back. Did you guys get an announcement on that? No, they have not sent you an announcement. Well, we are scheduled to go back after spring break, just so you guys know. And how we go back, it's going to be it's going to be different, but we are scheduled to go back after spring break around, I think it's April 5th. And so we will finally get a chance to see one another if you choose to go to school. And there will be two groups. Half the class will be in school and then half the class will be at home. It's going to be a split setup. I'm surprised they haven't told you that, but it's going to happen. And yes, Rebecca, you're going to have a choice of, I think, unless they alternate, there's going to be, I think, two groups. So if it's what I'm thinking, not sure if they just switch alternate. So one group goes into the school one day or 2 days a week, and then the other group stays home, and then you switch. I'll have to get the specifics on that because things are being worked out as we speak. So yes, we will be able to see each other finally, which would be kind of nice. And you guys are going to be able to see your friends and colleagues, classmates at school, believe it or not. And there is more action at school. I don't know if you've been to school lately, but the sports are starting to participate at school. And school is starting to become more normal nowadays, so which is kind of nice. Everybody's been waiting for that, and not just the students, but the teachers too, because school is a lonely place without you guys, because without you guys, we don't have a school. So I'm looking forward to it. It's going to be different. As I know more specifics, I'll let you guys know. Hopefully I should know next week what the specifics are. And I'm kind of shocked that they haven't sent anything home. So maybe I shouldn't be even saying this, but I just want to let you guys know. Okay. Chris and Audrey and Cameron and Jana, you guys should have your cameras on. If not, you got to send me a private message and let me know what in the world's going on. Okay. This is standard protocol every day. I want to be able to see you guys. Students, every student that engages in my class, meaning with your cameras on and you're participating in the chat and you're asking questions, every single student is passing my class. And a lot of you guys are doing exceptionally well, like A or B. The people that are struggling, that are barely passing the course, whether it's this class, financial algebra, or the other class, MRWC, the only people that are struggling are the people who seriously don't attend class, don't do their assignments, don't participate in the chat, and don't participate. And that kind of makes sense to me. So if you guys work with me here, give me your best in class and participate, you guys are going to do really well. So let's keep that up. Have a great attitude, work your best, ask questions, interact, make the most out of your time. Okay. Let's see, Cameron, Cameron, I got your message. Audrey, I got your message too. Thank you. All right. Well, let's get started here. Unless you guys have any questions here. Any questions or comments before we work together here for a few minutes? Because I'm going to work through part of these problems with you guys. The first half, basically. And the second half I'm going to give to you. Okay. Well, then let's go for it here. Haven's coming in. All right. Now, this is kind of a cool section because it deals with some realistic things. And one of the mathematical topics that is involved in here is what's called a piecewise function. And that is the only challenging and difficult thing in here. So there are a couple challenging ones. And what we'll do is we'll slow down when we get to those and make sure we understand fully what a piecewise function is and how to build it. Working with it is easy. Writing it is a completely different manner. Okay, so I'll get started here in just a minute. Let me bring Matthew in. Okay. All right, so let's read the problem, of course, get familiar with it here, and let's interact with each other. Matthew, glad you made it here. We're starting chapter 5. Okay, join us here. There you go. I like that thumbs up, buddy. I like your attitude. Okay, so number 1, Mitchell found a job listed in the classified ads that pays a yearly salary of $57.3K. We got to figure out what in the world does that mean. So let's underline the key stuff here. So always get a red pen out and annotate a little bit. And then we'll do all the, stuff in black, but we'll point out all the important stuff in red, okay? The question is, what is the weekly salary based upon the annual salary? So we need to figure out what this is right here. So let's, what is the weekly salary? What is that? Well, so first of all, the K notation is common in business. So when you guys go get a job after college or during college, you'll probably get your career started after college, after 4 years, most of you. All right, they use this K notation. So do you guys know what that means? You know what K means? Does anybody know what K means? 57.3K?
1,000.
Yeah, you know what it's abbreviated or like the word? I know it's as a numerical number, it's 1,000, but you know what K stands for as a word? You might have seen it in science. It's kind of like kg. I don't want to say it, I'll give it away. km. You see that instead of miles per hour, you see km on your speedometer, on the inside of your speedometer. Yes. Okay, there we go, you guys. You can use your mics. It's more fun when you guys talk. Okay, kilo. Yeah, K is kilo or 1,000. So Shannon, you were on it. Okay, and it comes from the word kilo or 1,000, like a kilogram, 1,000 gram, or a kilometer, 1,000 meter. Okay, so let's put that at the top. K stands for kilo typically, all right, which numerically is 1,000. Okay, so when you want to figure out what 57.3K is, you got to multiply it by 1,000. If you need a calculator, be my guest. Okay, so get one off to the side. I'm just going to be using our basic little scientific right here. So if we need this, we can use it. Although most of these problems you can probably do in your head, but when you need it, you go ahead and use it. Okay, so here we go. So 57.3K is going to be equal to 57.3 times 1,000. So times 1,000 here, because you need to get a yearly salary. You need to know that as a number. Okay, so when you multiply by 1,000, you simply shift the decimal point 3 places right. Okay, I'm a little fired up today. So that's 57,300 if you shift the decimal 3 places right. And that's per year. So the way you write that is put a slash and then you go per year. Okay, annual means per year. But in this problem, they want to know weekly salary. So my friends, all of you guys out there, all my financial algebra students, how many weeks per year? Show me on your fingers. Boom, give me a quick response. There we go. Yes, there are 52. Okay, 52 weeks per year. So what we need to do, here we go. So if that's our annual salary, we're going to take $57,300 per year. Okay. And we're going to multiply it by 1 year per 52 weeks. Now, in the video that Mr. Alex produced, he talked about unit conversion, and this happens in this section here. So you need to multiply by what's called a conversion factor. You notice that the years cancel out right there. 1 year, year divided by year cancels out. The units cancel out just like numbers, believe it or not. You see this a lot in chemistry. You see it in physics. It also happens in mathematics and business. Okay, and what we get is 57,300 divided by 52. So that's where your calculator comes in. So go ahead and go for it here, guys. Participate with me here. Type that in. What's 57,300 divided by 52? And obviously you got to round it to the nearest penny, right? So go ahead and do that. Put your answer in the chat or just speak up. Those that participate simultaneously will do the best, okay? Let's participate. There we go. Thank you, guys. There you go. So $1,101.92, okay, per week. Okay, so there we go. There's your first one right here. So this is equal to $1,101.92 per week, okay? So WK stands for week. Oh, I didn't mean 52 years. I mean 1 year per 52 weeks. Sorry about that. Look, I'm going to fix this little abbreviation right here. 1 year per 52 weeks, WK. Sorry, guys. Fix that right here. I'm a little excited this morning. I've been up since 5. My miniature donkey woke me up at 5 o'clock. I can hear him all the way down below in the corrals. And he keeps on honking at me every 30 minutes until I go down there and feed him. So he motivates me to get up real quick and go down there and feed him before I get started on my day. Yes, I do have a donkey. Okay. Oh, hey, you know what that reminds me, you guys? So give me some feedback right here. I was thinking about having an open house at my ranch. So hold the phone right now. Everybody look at me up here. I was thinking about having an open house for my seniors so I get to meet you and have you guys to come to my house, and I'll do like a big barbecue. I have a smoker and I know how to really barbecue really well. I'm like a pit master. And I was thinking about like having a 4-hour period where you guys can just show up anytime between like 12 and 4 at the ranch. You can meet my donkey, Honky Donk. You can meet my horses. You can meet my, I have a piggy. Her name's Charlotte, and she's a handful. And then you can meet my Great Dane, my Frenchie that I told you guys about. By the way, a little update on French Bulldog. His name is Romeo. He's going to the vet today to get a checkup on his eye, and he's looking a little bit better, but we're still concerned about his eyes. So I'm going to take him there and see how he's doing. So just out of curiosity here, give me a feedback on this screen. Who would actually come to an open house with Ainsworth here and meet your instructor and maybe have some good barbecue? Who would like to do that over spring break? You just can show up at any time, you know, between a certain period of time. Give me a show of hands. Come on. Who would actually come? Because I'm not going to do this if you guys don't come. That's a lot of people. Okay. And that way I can actually get to see you face to face. Oh God, that'd be awesome. Okay, I will. Now, if we do this, you can't tell anybody because I don't want to jeopardize my job. Okay, I don't even know if I'm allowed to do something like this. But I'm willing to, you know, live life on the edge, be a rebel. So I'll arrange it. Okay, and then I'll get a possible date to you guys before spring break happens, and I'll plan a day and a time for you guys, and I'll cook up a storm. Okay, and we'll have some awesome barbecue, and then you guys can meet my crazy animals too, in addition to me. So that'd be fun. All right, so I'll make a note of that. Okay, so hey, say Ainsworth, get focused. I got to get focused here. Sometimes I tell too many stories, get off track here. Someone say, hey, Ainsworth, get focused. No, it wasn't. You guys are funny. Okay, let me get started. Okay, let me read the next one. We'll do a couple of these. Like I'm saying, I'm going to do most of the first page here, 1 through 9. There are some really key problems on the first page here, so I have to do it. And then the second page is mostly going to be on your own. But okay, number 2. This was a simple one. So Clarissa here is considering 2 job offers. This is going to happen to you guys. One has an annual salary of 61.1K. Okay, so that's the first one right here. All right, and the other one has an annual salary of 63.4K. That's the second one. So we have 2 different jobs. Okay, what is the difference? Okay, what is the difference in weekly pay? That's what we want to figure out. So we have to do a few things. We have to calculate the weekly pay for both of them because they don't give us the weekly pay, they give us the annual pay. So this relates to question number 1. So here we go. On the first one up top. Okay, let's start off with the first job at 61.1K. So we got to take 61.1 per year and we got to convert it to 1,000. So first one, 61.1K is going to be 61.1 times 1,000. All right. You have to know what that means. So what you do is you can multiply it by 1,000 on your calculator, but guys, you guys can do this in your head. You just shift the decimal 3 places right. All right, and so that's 61,100. That's the first job. Okay, this is per year now, per year. So let's go per year. And then of course we have to change that to weekly. And we're going to do it the same way we did up top in number 1. We have to multiply it by 1 year per 52 weeks. So here we go. So times 1 year per 52 weeks. And let's get a number. Now in the units wise, the years cancel out, and that's how you get to shift to weeks. So you got to take 61,100 and divide it by 52. All right, go ahead and do that. Let me know what you get. No, I'm not going to do that. You guys do that, okay? All right, let me know what you get. Put it in the chat. Okay, I agree with that. So 1,175. So this is right here for the first one. So $1,175 per week, per WK. That slash means per. So the first job, this person, Clarissa, could earn $1,175 per week, which by the way is not bad. You multiply that by 4 and that's per month. That's a good number right there, guys. Okay, now next job. Okay, so the next one, annual salary is 63.4K. So 63.4K is 63.4 times 1,000. Okay, this is very typical. You guys are going to all encounter this when you get out of college and you get your first job. This happens all the time, this lingo. So that's 63,400 per year. And again, to change it to weeks or per week, you got to multiply it by 1 year, all right, per 52 weeks. And you're going to get a number there. So you're going to take your annual salary, 63,400, and divide it by 52. And it's going to be different. So go ahead and tell me what that is in the chat. Okay, what is that number there? This one's different. All right, and try to participate in the chat. Either agree, disagree. If you're coming up with different numbers, you better speak up. I happen to agree with that. Okay, so this one here, on this job, the second job here is $1,219 and roughly 23 cents per week. So it goes slash WK. That's per week, which is not bad, by the way. That's almost 5,000 per month, guys. That's an excellent salary. Okay, and so now what we want to do is calculate the difference. It says, what finds the difference? How much more is the second job earning per week more than the second one? So the difference, so we take these and let's calculate the difference. You got to subtract the big one minus the small one. So you got to take your 1,219.23 and you got to subtract the 1,175. So how much more per week does the second job give you? And these are decisions that you guys are going to be making later on in your life. That's why I love this class, because everything that we do is going to impact your life. You're gonna experience this sometime. You guys go ahead and let me know what you get up there. How much more per week? There you go. And it says round to the nearest dollar here, so that's close to 44 bucks. So it's about $44.23 more, or roughly 44 bucks. So 44.23 is exact, so it's approximately $44 more. Okay? And once again, this is these are really applicable things. You're going to experience all of this when you get your first job later on, you know, after your college years. Okay. Now, number 3 is a little bit different. This one deals with percentages and things, so we should probably do this one. Like I said, I always do, when I work with you guys in class, I always do a variety of problems to make sure that you guys have enough experience that you're all good and you can finish the rest on your own, you know, pretty easily. So when you come to class, you can expect that. So on number 3, Mr. Leonard took a job through an employment agency. The job pays $88K per year. That's obviously important. Okay, he must pay a fee. And this happens to, you have to pay for employment agencies to help you do a job search. If they find the job for you, you have to pay them because they did the work. And employment agencies are a big part of life. Okay, many people go to job hunters, or they're called headhunters, job hunters, whatever, and they go search for jobs for you, but you got to pay them to do it. He must pay a fee to the employment agency. The fee is 22% of the first 4 weeks' pay. That's important, so let's underline that. This is the fee now. 22% of the first 4 weeks' pay. How much money must he pay? This is a realistic thing. People encounter this all the time. All right, so what we need to do is figure out what 1 week pay is. And so he gets 88K. So here we go. So let's take your 88K, which is obviously equal to 88,000, all right, per year. And we need to convert this to a weekly salary. So we're going to go from annual to weekly. And every time you do this, you know, there's 52 weeks in a year. So you multiply it by 1 year per 52 weeks, always. So you're going to end up taking 88,000 divided by 52. Go ahead and help me out here when you're ready. Okay, very good. So that equates to, looks like $1,692.31 per week. So go / per week, okay? WK is per week. Now, the fee is based upon the 4 weeks pay. And so this part right here, the key part is we have to take 22% of 4 weeks pay, which is 4 times 1 week. So 4 times 1 week of 1692 times $1,692.31. Because it's for 4 weeks. It's 22% of 4 weeks, not 1 week. So you got to take your 1 week pay and multiply it by 4. Okay, now when you take a percentage of something, what's an important thing that everyone needs to remember? Because percentages come up a lot. What do you do with all percentages before you take 22% of something?
Change it into a decimal.
Yes, yes. Okay, so very good. And Kayla agrees with you. So 22% is 0.22. You take 22 divided by 100, or simply shift the decimal 2 places left, as you guys know. So 0.22 times 4 times this weekly salary of $1,692.31. So you just need to enter that in your calculator. You guys can do that. Round it to the nearest penny. And you're going to be pretty shocked at this number. This is a pretty good sizable number. Let me know what you get when you're ready. Okay, there you go. That's a good sized number right there. That's a pretty big fee. So these employment agencies can make quite a bit of money by helping you find a job. Okay, they get you have to pay them $1,489, $1,489.23. That's a lot. That's surprising. All right, but here's the deal: it's worth it. If you're making 88 grand a year, that's a very, very good income, guys. You can live on that, no problem. All right, so paying roughly almost $1,500 to help you find a nice job, it's worth it. Okay, and versus trying to find a job on your own, it's sometimes difficult. Okay, especially if there's a lot of competition. So employment agencies are going to be a big fact of life when you graduate college, either as a business major or whatever you guys plan on doing. By the way, speaking of that here, go in the chat. Everybody give me a response on this. What do you want to be when you graduate? Do you want to be a finance person? Do you want to be a veterinarian? Do you want to be a doctor? Tell me what you want to be in the chat. Everybody give me a response. What is your goal in life? What do you want to become? What do you want to do later on in life? So I'm just going to be looking at your responses here. So Shannon, the travel nurse. Oh boy, this is happening fast. So graphic designers, PA, dermatology, a veterinarian, a doctor, therapist, animator, mortician. Okay, animator, accountant. Cool. Well, this class is for you. Psychologist, firefighter. Tristan, my wife's family are all firefighters. Commercial pilot. Grant, my son's studying to be a pilot right now. He's at EFI in French Valley. And then Chris, firefighting business owner. Justin, not sure yet. That's understandable. Garrett, mechanical engineer. My father was a mechanical engineer. I almost became an engineer. And Matthew wants to start his own business, entrepreneurial. And then Tyler, Fire Academy. Wow, that's pretty cool, you guys. Thanks for sharing that. Well, this is an exciting time for your life, you guys, because going through college or a trade school or Fire Academy or anything or pilot school, whatever you guys are going to be doing, is exciting. Really, really cool. Okay, let's see. We're going to skip 4. Let's go to 5. Okay. Now, number 5 is a key problem. Let's start in the margin here. This deals with what's called a piecewise function. So there's two main mathematical portions of this lesson in respect to piecewise functions. First part, you have to know how to use it and how to work with it, because in business, it comes up a lot, okay, as you're going to find out. And then the second part of it, the harder part of it, is how to write the piecewise function. So part 1, like on number 5, how to use it, how to work with it. And then the second part, how to write one, which is a little bit more challenging. All right, so this is a key problem here. So circle number 5. Okay, you saw this probably in Algebra 2. Hopefully they went in piecewise functions with you. If not, you're gonna learn it from me. So number 5, Ariel owns a Levitt Construction Corporation. She needs a welder and is placing a 7-line classified ad. Okay, so advertising agencies design their price structure like this. Okay, all advertising agencies do this. The cost of an ad, so this is cost. So let's label this. So this is cost right here in dollars. C of X is cost. The cost of an ad is X lines long. So that's key. So X stands for number of lines. So X equals number of lines in the ad. All ads are the price of the ads are always based upon the number of lines, because back in the day in newspapers or in magazines where the ads are, all right, it obviously takes up space, and the more space you take, the more it costs. So this is a real life thing. Nothing's made up here. So the cost of an ad that is X lines long is given by the following function. So C of X is called the cost. X right here, the variable is the number of lines. So this represents the number of lines. It's called the domain of the function. And then 33 or the second part right here represents your cost. So this is the cost. And then the second part here, when it says X less than or equal to 4, represents the number of lines. Okay, so the cost, if you want to read it, piece number 1, there's 2 pieces here, piece 1 and piece 2. So label them. the cost for 4 or less lines, notice how I say that, 4 or less. When you say x is less than or equal to 4, that means 4 or less. So 1 line, 2 lines, 3 lines, 4 lines is going to be $33. Okay, whether you have 1 line long or 2 lines, it's a flat rate. It's constant right there, and it's going to be $33. If you go more than 4, it says right here, the second part. So let's focus in on the second part right here. If you take a look at that part, if you're more than 4, greater than 4 means more than 4, like 5 lines, 6 lines, okay, 7 lines, you're going to be paying $33 plus 5 times whatever x is minus 4. Now it says find the cost. Let's look at what we want here. So this is what we're trying to find. Whoa, that's not good. Okay, we're trying to find the cost of a 7-line add. So in this case, since x is equal to 7 lines, all right, we're going to use the second piece number 2. Now, a piecewise function may have more than one piece, or more than 2 pieces, by the way. Just so you know, it could usually in real life situations, it has multiple pieces. I mean, way more than 2. But in this is a simple function, a simple price structure. Okay, so if you're greater than 4, and 7's greater than 4, obviously, you're going to be using this function right here. So C of 7, that's how you write it, C of 7. C of 7 is equal to your $33 here. It's going to be $33. We're using the second piece right here, plus 5 times whatever x is, which is 7, minus 4. You just substitute 7 into the function and evaluate it. And then if you watch the video with Mr. Alex, he talked about following the order of operations, and doing some simple arithmetic. Although you could enter that in decimals right there, although I don't think you need to. 7 minus 4 is 3, so this is 33 plus 5 times 3. So that's 33 plus 15, obviously. 5 times 3 is 15, and 15 and 33. You guys tell me, what do we get total? What's the total cost? You can just speak up if you want. What's the total cost? This is where we participate. I can't do it all for you guys. Come on. All right, $48. Okay. Now, advertising agencies always have their price structure using piecewise functions. That's why it's in here. If you go if you go to a printing company like Kinko's, for example, they have their price structure is by using piecewise functions. If you buy business cards, like I have business cards for my tutoring agency, because I tutor on the side 1-to-1. People come into my house, I tutor them in mathematics at all levels, and I have to make a bunch of business cards, like 500 to 1,000 business cards. And when I do that, the price structure at the places where I buy my business cards are all given by piecewise functions. This is apparent in all kinds of different companies. So that's the application. The formation of one that's different. So before I try number 6, which is your second key problem here, how we do on number 5? Do you understand why we chose the second piece versus the first piece? You understand the evaluation? Give me some feedback right now. How we doing? I can see you guys. You can give me physical feedback or you can give me feedback in the chat, either one. I'm looking at you guys, big and bold. You're on my big 32-inch screen here, so I can see you guys. Thank you, Sierra, Matthew, and a few others. Okay, so, all right. So number 5, you evaluate the function. Number 6, you write the function. This is more challenging. This is where I say get another piece of paper out because we're gonna have to go off to the side. Okay, so number 6 is a key problem. Numbers 6, 8, and 9 are key problems. These are all key problems here. Okay, so let's work it through these out. All right, so Carpenter's Chronicle, okay, charges $12 for each of the first 3 lines in a classified ad. Okay, so this is some kind of, they either make magazines or something like that, or newspapers. So it charges $12 for each of the first 3 lines So that's important. So let's underline that part. And then, and here, it's $7.25 for each additional line. So that's different. So it costs an additional amount, $7.25 for each additional line. Express the cost of an X line add. So the cost here is called C of X. So C of X is going to be equal to some piecewise function. And we're going to do it algebraically. Now, this is going to be a two-piece function. So there's going to be a first piece right here if, on some condition, and the second piece right here on another condition. So what we want to do is go off to the side, and what we're going to do is we're going to set up a table of values to try to understand it. If you're really experienced with writing piecewise function, you can probably just read it and write it if you're really experienced. But if you're not, I would highly suggest you develop a table of values so you can see the pattern, because when you do that, it becomes much more clear and it becomes a lot easier. All right, so let's do this. So X is going to be the number of lines in the add. So let's set up a table of values over here off to the side. This is why I said get another piece of paper out, because you can't fit all this on the worksheet. You're going to be doing this for number 6, number 8, number 9, and one more on the back. And you're going to be needed to submit all this work here when you submit your work in Canvas. So I see you guys getting additional paper out. Take a minute and do that, because you're going to be doing this for at least 4 different problems. Give me a thumbs up if you're ready. Okay. All right. So X is going to stand for a number of lines. C of X is our cost. So let's label up at the top. X is going to be the number of lines. And then C of X is called the cost in dollars. And what we want to do is kind of go outline what it costs for 1 line, then 2 lines, then 3 lines, then 4 lines, and look at the patterns. And when you see the patterns, you're going to be able to see how the function's written. Okay, so here we go. So let's reread the problem to get familiar with it. So it says up here, it says $12 for each of the first 3 lines. Okay, for each. The word each is important. So for 1 line, okay, when X is equal to 1, it costs $12. So there's only 1 times $12. It's $12 for the first line. Now it says $12 for $12 each for the first 3 lines. So if you want 2 lines, if you want to make a 2-line add, all right, it's going to cost you 2 times 12. You got 2 lines, and each line is $12, and so it's going to cost you a total of $24. Now don't just write down 24. Write down 2 times 12 equals 24, because you're going to see a pattern here. All right, and the only way you see a pattern is understanding how you're calculating. And we get 24 because each of the first 3 lines costs $12 each. So if you want 2 lines, well, it's 2 times 12 or 24. For 3 lines, well, let me see. It says $12 for each of the first 3 lines. So if you want 3 lines, then it's going to be 3 times $12, or a total of $36 for the first 3 lines. And then things change after that. Okay, so at this point right here, let's just take a look at it right here. Let's just draw a line right here, because after this, things change. So at this point right here, in terms of the function right here, notice that you're multiplying the number of lines right here. You're multiplying the number of lines right here times the cost. So if this is in general X, this is X equal to this, it's going to be X times 12 in general. So this first part of the function is going to be whatever X is, the number of lines, times the cost, or simply 12X dollars. That's going to be the total cost for the first part of the function if X is less than or equal to 3. It's for the first 3 lines only. After that, the price structure changes. And that's the first part of your function right here. So let's go to your piecewise function and write down 12x. C of x is equal to 12 times x right here. if x is less than or equal to 3 lines, okay? That's piece number 1. And let's ask questions as we go. So if you're not making sense, or if you need me to repeat something or go into more detail, you got to let me know. Because if you fully understand these examples, then you're going to be able to do something similar on your own. But if you're not understanding what I'm doing, well, then it's time to stop, pause, and ask questions. So don't be afraid to speak up at any time. You guys with me on that? Give me a thumbs up if you're with me on that. Communicating with me effectively, okay? Asking questions as we go. All right, you got to search for deep understanding, not surface understanding. Okay, now at the 4th line, when you get to 4 lines, price structure changes. This happens in every advertising agency, okay? When you want to advertise in a magazine or a newspaper or even online, it doesn't matter. The price structure changes. Now it says, right up here, it says, if you want more lines, it says $7.25 for each additional line. So if you want 4 lines, okay, you're still going to have to pay the $36 for the first 3 lines. So you got to start off with that. Plus you're going to have to pay $7.25 for each additional line. And if you want 4 lines, that's going to mean you're going to have to pay 1 times that $7.25, because you only have 1 line more. I mean, if you're at 4 lines, then it's obviously 1 more additional line, which means you got to add 36 plus $7.25. So where are we at? What's the total right there for 4 lines? What's 36 plus 725? You guys got to help me out a little bit here. You guys can use your microphones, people. Come on, guys. There we go. You guys prefer the chat. That's fine. So $43. So 36 and 7 is 43. So 43.25. Okay. Now, to see a pattern and to really understand the cost-wise function or the cost function, you need to do it a few more times to see the pattern. So let's do this. So let's say you want 5 lines. Well, if you want 5 lines, you're still going to have to pay the $36 initially for the first 3 lines, plus you're going to have to pay for your additional lines. So if you want 5 lines total, you're going to have to pay for 2 additional lines, right? 5 is 2 more than 3. So you're going to have to pay for 2 additional lines, and each one costs $7.25. So notice I put the 2 there. It's going to be 2 times that because you want 2 additional lines. You know, 5 is obviously 2 more than 3. Now use your calculator when appropriate. If you can do it in your head, great. If you can't, use your calculator. Give me a number in the chat quickly here. Just you guys give me, you do all the arithmetic. And then I'll just kind of go with the flow and go through it together, okay? So now you're at, there we go. So 50, yeah, so 14.50 plus 36, 50. So here we go. So now it costs $50.50. Now suppose, let's just do it 1 or 2 more times, then we'll write the function. Suppose you want 6 lines. Now if you want 6 lines, that's 3 additional lines, right? Because you're obviously 3 more than 3. So you still have to pay for the first 3 lines, which is a total of 36, plus you want 3 more lines. And each one cost $7.25. So just don't write the answer. When you guys are searching for the pattern in things, you have to write how you're calculating in order to see the pattern. And once you see the pattern, then you can write the function. This is how the function is developed. All right. So if you add, $7.25 to that, where are you at? That's 1 additional line, which is you have to add $7.25 to the previous value, and you get correct. There you go, $57.75. Okay, now check this out. Suppose you have X lines. Let's write the function now. So now you're at X lines. You could be 7, 8, 9, 10. It doesn't really matter. But notice that we're past 3 here, and you're gonna have to pay. You're going to have to pay the $36 for the first 3 lines, plus what? Plus what here to get the total cost. So before we answer that, take a look at the pattern here. Everybody look at my screen real quick. When you have 6 lines, it's going to be 3 times 725. When you have 5 lines, it's going to be 2 times 725. When you have 4 lines, it's going to be 1 times 725. So it's going to be equal to what number here times 725. What are we going to put in there? What is the relationship here? Is it going to be x times 725 or is it going to be something else? Look at the pattern. What's going to be the cost for x lines if it's greater than 3? How are we going to write that? Look at the numbers again. 6 compared to 3, 5 compared to 2, 4 compared to 1. And then take that pattern and apply it to x. What should we do with x to figure out what we multiply 725 by? What do you guys see in the pattern? It's whatever x is minus 3. 6 minus 3 is 3. 5 minus 3 is 2. 4 minus 3 is 1. So what you want to do is you simply want to take this guy and you want to subtract 3, which happens to be x minus 3. This is if x is simply greater than 3 lines, like 4 lines, okay? 5 lines. And this is your second part of the function right here. And so what we're going to do is we're going to say, okay, the cost of the function is 36 plus your x minus 3 times your 725. That's if x is greater than 3. Let's pause here because that right there is how you develop any piecewise function. You have to look for the pattern. Let's pause here and ask questions. And if you don't have any, type in, I'll get in the chat, meaning that you fully understand that last step, the critical step, the pattern recognition step. I see you guys on your screens, okay? Sierra and Alyssa and a few others, okay? Now this is how we approach the piecewise function for numbers 8 and number 9 as well. So, and in order to get good at these, you obviously need to do more than one example because, well, it takes a lot more practice than that. So this one was number 6. Let's go down. Let's shift to number 8. Okay. Since you guys didn't have any questions, let's go to number 8. This is another piecewise function example. Okay. So in this one, it's a little different company here. We've got Arts Printing Service charges $27.50 to print 100 high quality copies for a 1-page resume. So that's a flat fee. $27.50 for 100 quality copies. This is like a Kinko's or something. This is similar to a Kinko's example. Okay, so let's underline that. That's the first part of the function. So let me see. Each additional set, here's the second piece now. Each additional set of 100 copies costs $14.99. Notice the price went down. The more you order, the less it costs per unit. That happens in any business. Okay, express the cost C of R. So we have a function C of R is equal to, something. So it's going to have 2 pieces. Piece 1, piece 2. So and then R is going to be the number of sets of resumes. So R is equal to number of sets. In this case, it says it right here, R sets of 100 resumes. So, groups of 100. So what we need to do is go off to the side again, kind of outline it. What does it cost for 1 set, 2 sets, 3 sets, 4 sets? And when you see it in the table, then you write your function by looking at the patterns. Okay, so let's go off to the side again and let's do that. Here we go. So R is going to be representing the number of sets. number of sets of 100. Okay, and then C of R is your cost. C stands for cost in these examples. So C of R is equal to cost. By the way, is my speed okay for you guys? Speed of discussion here, is it good? Too fast, too slow, just right? Give me some feedback. Okay. All right, so what we want to do is figure out for 1 set, 2 sets, 3 sets, 4 sets, and then get an idea of what's going on. We look at the patterns, and then we write the function. Okay, so here we go. So let's always reread the problem. I usually reread the problem 2 or 3 times to make sure I understand what in the world's going on. It says up here at the top, they charge $27.50 to print 100 high quality copies. That's 1 set only. So that's a flat fee. So there we go. That's our first thing we know. So when R equals 1 set, this is again, these are sets. Okay, the cost is equal to $27.50, flat out. That's when R is equal to 1. R equals 1. Then after that, things change. Okay, so I'm going to switch here. So after that, for 2 sets, things change. So already we know what the, and this is constant here. This is just a constant number. It's not a variable number. It's just the first set is $27.50, constant. And that goes up here. So $27.50, okay, when R is equal to 1. Just flat out, first set's $27.50. After that, the price is reduced for the set, and it depends on how many sets you want to buy. That's the first part of your function. Now let's calculate it for 2 sets. Here we go. Now, if you want 2 sets, like I said, in the printing company, it says it costs $27.50 for the first set. So here we go, $27.50 plus an additional amount. So it's $27.50 plus whatever the additional amount is. And if you want 2 sets total, well, it's the first set plus the second set, but the second set, the price has been reduced to $14.99. It's cheaper. The more you buy, the cheaper per unit price it is, which is a very, very common thing. So when you want 1 additional set, you have to pay an additional $14.99 for that. And this is where you guys come in. Calculate that. What's $27.50 plus $14.99? There you go. Man, Aaliyah, you are on the calculations here. Okay. So there we go, Audrey, Kayla. So 42.49. So the cost for 2 sets is $42.49. Okay, now let's 3 sets. If you want 3 sets, well, you got to pay the cost for the first set. That doesn't change, $27.50, plus the cost for 2 more sets, 2 additional sets. So if you want 2 additional sets, it's going to be 2 times $14.99. Make sure you write down the process right there, because if you don't, you're not going to see the pattern. And if you don't see the pattern, it's going to be kind of hard to write the function. All right, that's the key. That's why I'm taking time to do this. So can you guys help me out with that, please, when you're ready? What is $27.50 plus 2 times $14.99? There we go, Chris and Sierra. There you go, $57.48. Now let's do this one or two more times so you can see the pattern. You can only see patterns when you've done this a few times. So for 4 sets, you still have to pay the first set is always $27.50, always in this price structure. Okay, plus, and if you want 4 total, well, you need 3 additional sets. So 3 times the cost for each additional set, which is $14.99 for every additional set. Question is, what is that? Everybody should be calculating simultaneously. This is how you get good. This is how you fully understand what's going on. There you go, Justin and Kayla. So you guys agree with 72.47. Okay, so 72, excuse me, yeah, I said it right, $72.47. Okay, now let's jump and let's see if you guys can figure out the pattern. Everybody look at the table on the screen here. So we want to figure out what would be for R sets. R, that's an R, okay? So look at the pattern here. If you're buying 2 sets, it's $27.50 plus 1 times $14.99. If you want 3 sets, it's $27.50 plus 2 times $14.99. If you want 4 sets, it's $27.50 plus 3 times $14.99. So let's jump to the abstract here, guys. If you want R sets, which is obviously greater than 1, it's going to be $27.50 plus what? This is where you guys come in. What are we going to do to this by looking at the pattern? What are we going to do with R? Yeah, see, you guys are starting to see it. Okay, it's -1. It's whatever R is minus 1. So it's R minus 1 times your $14.99 for each additional set. If R is greater than 1, greater than, use the greater than symbol. Okay, this is your second piece of the function. Okay, so let's write it up here at the top. So we got $27.50 plus R minus 1 times $14.99 if R is greater than 1. Okay, any comments or questions on that one? This is the basic idea of how I approach all piecewise functions. And then when you get really experienced on this, you can probably go straight to the function when you get good. But, you know, in the learning process, you know, it takes a little development. You guys have any thoughts on this one? Any questions? Giving you guys a chance to reflect and make sure you fully understand here. Logan, is your hamster learning how to write a piecewise function?
Oh yeah, he definitely is.
He's going to become the piecewise master hamster?
Yeah.
So yesterday in my MRWC class, one of my students always has her cat right behind her. And she told me that the cat always watches my lesson for at least 30 minutes, like totally stares at the screen for 30 minutes. And with my class only, not any of the other classes, but with my class, for some reason, it's an MRWC class. The cat always comes in right behind her and watches the lesson. It cracks me up. So we call him the catamatician. All right. So Natalie, is it with this class or all your classes?
It's with all of my classes. Like, she'll just sit on my computer and she'll start to purr, and I'll move my mouse and she'll just like attack my screen, and she's logged me out multiple times, and it's like, it's so weird.
So you have a catamatician too, huh? All right, that's cool. It's funny, my Great Dane. Have you guys seen my Great Dane yet? Yes or no? I'm talking. She stands and she's this tall just by just standing here. She watches TV, and it's amazing. She just sit out. She'll sit like you guys do on the couch, and she'll watch TV when I'm watching TV. It's the craziest thing. My Great Dane likes TV. Don't understand it, but just how it is. Oh, Shannon, Akita. Oh man, you have to show me your Akita one of these days. Those are awesome looking dogs. Okay, Ainsworth's getting off track again. Okay, tell Ainsworth to focus again, guys. Focus. Oh, Haven, I love that movie. That's one of my favorite movies. I'm a I'm a cartoon junkie. I love, like, you know, The Incredibles. I love all those movies. How to Train Your Dragon is an awesome one of my favorites. Okay, I'm sorry guys, I'm talking too much. You guys accept my apology? Okay, Ainsworth will stop talking, okay, and I'll get focused here. Okay, so number 9, last one I'm going to do with you guys, because this is another piecewise function here, and then you guys should have enough experience to do the rest on your own. Okay, Yoko here needs 300 copies of a resume printed. Oh, resume time. We're going to be talking about resumes this chapter. You're going to make one. So hey, get ready for that. Dakota Printing, that's the company, charges $19.50 for the first 200 copies. Okay, and then $9 for every additional copy. So here we go. Part 1. This is part 1 right here. $19.50 for the first 200 copies, and part 2 right here, $9 for every additional 100 copies. Okay, so how much will 300 copies cost, including sales tax? Okay, so we gotta figure this out. So we'll do part A first. So let me see. So 200 copies, or let's say the first 100 copies, the first 200, excuse me, cost 900. So 200 copies. Okay, that's looks like 1950. So 1950. Now, if you want 300 total, well, that means you need 100 more. So you need 100 more copies, guys. This will happen to you later on when you graduate college. You're going to make resumes and you're going to send them out, and you're going to need a lot of copies to send them out everywhere. Okay. And nowadays we do a lot of things online, but back in the day, in my day, before the internet, we had to make a lot of copies. And this was a fact of life. Now, if you want 100 more copies, that's an additional $9. So plus $9. Okay. And so we obviously get a total here. You got to add those two. Okay, so what's 1950 plus 9? Well, 19 and 9, 28. So right now, it's going to be 2850 total. Now, things have what's called sales tax, and you have to pay. This is really an old example. Right now, sales tax is way more than 4.5%. Do you guys know what sales tax is typically nowadays? Because this is old. This is outdated. Do you guys know what sales tax is approximately? Give me a number. Throw a number in the chat. Yeah, it's close to that. Okay, so it's around 8 or 9. I don't even know exactly what it is, but it's up to 8 or 9%, 8 something, 8%. So this is outdated. So this is 4.5%, 4.5, 4.5 is 4.5% right there. And as a decimal, that's 0.045. So when you change a percent to a decimal, you divide it by 100. Percent means per 100. Okay, so what we need to do is we need to add 4.5% of this. We got to add the tax. So this is going to be plus 0.045, or 4.5% of the total. So 0.045 of the total, or times the total, 2850. So you can enter that entire thing on your calculator there. So what's 2850 plus the 4.5% times 2850, which represents your tax? This is a tax right here. What are you guys getting up there? You can enter the entire thing. You can do it in 2 steps or 1 step. You can calculate the tax separately and then add it to the 2850, or you can type the entire thing in Desmos or on your TID4, whatever you're using. Okay, and then get a total number there. But bring it on, guys. Let me know what you're getting. 2850 plus the 4.5% times 2850. You always multiply the percentage times the total to get a tax. There we go. And there you go. Leah, Natalie, Talia, and Rebecca all agree on 2978. So do I. Okay, so you always multiply the percentage times the total to get a tax, and then you add it to the original. Then you get 2978. Okay, now to the harder part. If the number of 100 resume, or the number of sets, okay, this is the key part here. So if the number of sets is R, so R is equal to the number of sets of 100. I always write down what my variables are. That's called defining your variables, because if you don't know what they mean, then you won't be able to write your function, okay? So you always define your variables first. R equals the number of sets of 100. Okay, and it says express the cost. So here's the what we want to do. We want to express the cost, which is C of R. So there's your cost. So C of R, C stands for cost, is going to be some piecewise function. And it's going to be a two-part function again. And so we got to figure this out. And what we're going to do is we're going to develop a table of values to figure it out. So I'm going to just go down here and develop a table of values. Okay, so here we go. Let's do the table. So remember, R is the number of sets, and the C of R represents the cost. Just out of curiosity, is anybody working ahead on this one, on the table? No worries. Okay, let's work together. Okay, so we figure out the cost for 1 set, 2 sets, 3 sets, 4 sets, and then once you see the pattern, you write your function. Okay, so for 1 set of 100, remember this, these are sets of 100. Okay, you guys talk to me here. This is 1 set. Okay, of 100 copies. What does it cost for 1 set? Either talk to me, turn your mic on, or go in the chat. What does it cost for 1 set of 100? Got to help me out a little bit here because you're going to be doing this on your own. Talk to me, guys. What does it cost for 1 set? No, go back and read the problem. Go back and read the problem. Okay, there we go. It says up at the top, he needs 300 copies. Yoko needs 300 copies. Or excuse me, it's a she. Yoko needs 300 copies, but it says the Dakota Printing Company charges $19.50 for the first 200 copies. Okay, so right here, this is important. The company charges $19.50 for the first 200. So if you only want 100 copies, it's going to cost you $19.50. Again, this is 1 set of 100. Sets of 100. That's important in the problem. So 100 copies equals 1 set. 200 copies means 2 sets. 300 copies means 3 sets. 400 copies means 4 sets, and so on. So 1 set, it's going to cost you $19.50. Now, if two sets, what's the cost of that going to be? Are you sure? Yeah, see, whether you want 1 set or 2 sets, the cost is the same. Okay, the company's only going to charge you $19.50 for the first 200 copies. So if you want 100 copies, they're going to charge you $19.50. So you might as well get 2 sets. You might as well get 200 copies because guess what? It's going to cost you $19.50 no matter what. It's a flat rate. So it's still $19.50. So let's pause right there. Does that make sense? It doesn't, Aaliyah, does that make sense? The price doesn't change from 1 to 2 sets. So you might as well purchase 2 sets. Okay, so this is constant for the first 2 sets. Okay, and that right there is where things change. After that, things change. So I'm going to switch colors here. So this is the true if R is less than or equal to 2 sets. And this is their first piece of the function right here. It's going to be a constant flat rate. It's called a flat rate of $19.50, whether you want 1 set or 2 sets. So let's go up here to the function. and it's going to cost you $19.50 if R is equal to less than or equal to, less than or equal to 2 sets. It's constant. It's a constant function. There's not a variable involved. It's going to cost you $19.50 whether you want 1 set or 2 sets. It's constant. It's called a flat rate. Are we good with that, you guys? Okay, I can see you on the screens. Thank you. Okay, now things change. When you want 3 sets or 300, things change. So I'm going to switch colors here. So 300 copies. 300 copies means that you need 3 sets. Now things are going to change at that point. So if you want 3 sets, Dakota Printing is going to charge you the $19.50 flat rate for the first 2 sets plus 1 more set, the cost of 1 more set. And the cost of 1 more set is right up here at the top. It's going to cost you $9 for every additional set of 100. So they're going to charge you another $9. They're going to charge you the $19.50 for the first 2, and since you want 1 more set, they're going to add in another $9. Okay, so you're going to add the $19.50 plus 9. It's going to be $28.50 total. Now, in order to see the pattern so you can write the function, we need to do this a couple more times. So if you want 400 copies, that means you're going to need 4 sets. Okay, and here we go. So the printing company is going to charge you $19.50 for the first 2, flat rate, plus the cost for 2 more sets, plus the cost of 2 more sets, and each set is going to be, they're going to charge you for $9 for every additional set. So it's going to be plus 2 times 9 because you want 2 additional sets. So what would that be? Can you guys help me out with that right there? What's $19.50 plus 2 times 9? There we go. You guys are calculating. There we go. Good, good, good. So we've got $37.50 here. Now let's do it one more time. If you want 500 copies, that means you're going to have to pay for 5 sets total. Okay. Now the company's going to charge you $19.50 for the first 2, flat rate. So it's going to be $19.50 plus the cost for 3 more sets. Because if you want 5 total, well, that means you're going to have to pay for 3 additional sets, and each one costs $9. So what are you guys coming up with right there? There you go. Good job, you guys. So it's going to be $46.50 in this case. Now, let's say we want R sets. Okay, let's jump to the variables here. So before we do that though, let's look at the table and let's find the pattern. So check this out. If you want 5 sets, it's $19.50 plus 3 times 9. If you want 4 sets, it's got to be $19.50 plus 2 times 9. If you want 3 sets, it's going to be $19.50 plus 1 times 9. So for R sets, it's going to be $19.50 plus what? And Chris and Justin, you guys are agreeing with each other. Okay, and Rebecca too. So yeah, you're going to be subtracting 2. So you take whatever R is minus 2 times 9. And then as Justin put it, he put the 9 in front. That's cool too. You can write it as $19.50 plus 9 times the quantity R minus 2, which is a typical way to write it. This is if R is greater than what number? What does R have to be greater than? Show me on your hands. What does R have to be greater than? Yes, 2. Okay, this applies when you get more than 2 sets, when R is greater than 2 sets. Okay, this is your second piece of the function. So let's put it up top. Okay, so here we go. So 1950 plus 9 times r minus 2. And then if r is greater than 2. And that, my friends, is how it's done. That's how you develop a piecewise function, by looking at a table of values, by looking at patterns. And that's what's going to be the key in your work on the next page. On the next page there, let me see which one is involved. Oh, I accidentally deleted the next page. Hang on, what happened? Hang on. I accidentally deleted the next page. So let me grab it here. Ainsworth is getting a little crazy on the computer here. Okay, so here's your next page here. So on this one, you guys are going to be working on this. Number 12 is the similar problem. This is a key problem where you have to write the piecewise function. Yeah, this is the critical one here, number 12. And another critical one is number 14. You guys are going to be working on all of these with exception of this one here. You can skip 13. This is section 5.1. This one here, you're going to have to use the table. So a show table. I'm not going to do this one with you. I want to see that you guys can do this one on your own. So when you submit this into Canvas, I'm going to be looking at this one and a couple other ones and make sure they're right. And to get full credit on your assignment, I want to see the table on number 12 and make sure it's correct, make sure it looks good. And then so what we'll do is on Tuesday, when I see you guys next, we'll, if you need help on this one, if I notice that that there's a lack of understanding in the class, what we'll do is we'll do Q&A on this on Tuesday. So I'm going to start with Q&A on Tuesday, or if you need additional help, you can always see me in intervention later on today as well. You can do that at any time, you know, after school at 1:10 to 2:30 is intervention. All right, but those are critical problems there. You're going to be doing all of them except number 13. And then whenever you're ready, you can submit your work. Whoa, what happened to my lesson here? There we go. And submit your work here in Canvas. And then I think section 2, the section 2 video will be up over the weekend. You can handle that as well before Tuesday. So on Tuesday, I'll cover Q&A over this. If you need help on anything, I'll help you out. And then we'll get started on lesson 2. So you got to watch the video over the lesson. Excuse me, I got that backwards. The lesson video over the weekend. And then just finish your homework. Okay? Any questions or needs before I let you go? I thought you did exceptionally well today in the chat and participation. Very good. Okay, well, it looks like I need to talk to my wife about the spring break plans, huh? So, and to come up with a possible date for you guys to do a little, what do we call it? A open house at Ainsworth Ranch. We call, just so you guys know, we call our ranch Crazy Faith Ranch. Because we're believers, and that's what my wife named it. And then I'll have you guys over here one of these days during spring break. We'll pick a day, and I'll have to pick a good one for you and a good one for me. And then we'll do a little barbecue, and I'll get to meet you guys, and we'll be able to sit on the patio, eat some good grub, and you guys can meet all my crazy animals. Okay. All right. Well, listen, it was a lot of fun working with you guys today. You guys did a great job. Leave me with the big smiles out there. You guys take care. Have a good weekend. There you go. There you go.
Thank you.
You're welcome. You guys have a good one. Good to see you guys. And I'll see you soon. Yes, Natalie.
My cat Echo wants to say hi.
All right.
She's
Oh, turn your mic on again.
she jumped up right as we were talking about how, like I said, she gets up here and then she opened my door because I leave it cracked so she can come in. And then she just jumped up here and started touching my camera and was purring and everything. So, yeah.
All right. Your
All right.
little
You have a
cat-
nice day.
You too, Natalie. Take care. Alyssa, where are you? May I see you?
Yeah. Sorry, I was grabbing my charger for my computer.
All right. What's on your mind?
Nothing much. Just gonna get this all finished and then I'll turn it in.
All right. If you need some additional help, you can always see me later on in the day. I'll on anything if you need it. Okay.
Alrighty, thank you.
You're welcome. We'll see you soon.
All right.
Okay.